Welcome back, everybody. So this is Shadow Drone, and I'd like to introduce you to a new project. The Parrot is completed. I changed out the LEDs, the 3 waters with the 1 waters to save power, and they're just as bright. And I ended up buying these micro voltage controllers. They're smaller than a dime, and they allow you to take 22 volts, 12 volts, and 6 volts, and any voltage below 22, and scale it down to 0.01 volt. So I'm running 2 of those in the drone to supply the LEDs. But I've been wanting to actually design a frame myself. And I've been working on a little project I'm calling the X-1 Spyder. As you can see, it's on the scale. It's a postal scale. So here it shows you the weight of the frame that I designed. Okay, I based the frame off of a F450, but it's all completely 3D printed. And of course, the carbon fiber 330 millimeter length. They're 13 inches. And what I've done is I've created a 3D print model, which you can see here. I printed the top and the bottom, okay? And this is basically a copy of the DJI F450 frame here, but I made a few little changes to it. Instead, I made these little adapters adjustable for a 16 millimeter carbon fiber tube, as you can see here. And I've converted it into a Parrot style drone. Not bad, huh? And it's being held together by a M3 machine screws, size M3, 45 millimeter in length. And these babies are solid. Okay. Oops, I forgot a screw there. I need to put that screw in there still. See that? Yep. Now the cool thing about this, these have the nuts on the bottom, but the ones on the inside do not. It's because I noticed that when you screw these things through with an electric drill or a screwdriver, they get so hot going through. When they come out at the bottom, they literally burn you. Okay, so the heat basically molds them into the plastic. So technically you don't even need these bolts on there because this ain't going anywhere. It's like literally like thread locker. So the frame is a lot lighter than the F450 factory based on this design. This is a lot lighter than the F450 frame with all the copper in it. So basically the way I'm going to twist the power to this thing is going to be a simple wire positive negative connection. So basically I'm going to run all the wires through the tubes as normal and then solder them together in the center, positive with positive and negative with negative, and then run one lead off for the battery lead to reduce weight. The idea on this thing is to come in as super light as possible, and basically I am going to, and brace yourselves everybody, I've decided to try my luck with a Pixhawk again. Now, if you don't know my history with Pixhawk, I will tell you. My first flight controller was a Pixhawk 2.4.8, as you can see here. The one that I initially bought was a complete set, which came with the power sensor, telemetry, long-range telemetry system, and here's the input for the laptop, and then of course all your little peripherals, you name it, it's got it. Paid me a mini OSD, everything. The original set was $140 from a China website, okay, on eBay. Bought it about a year ago. It was pretty much DOA out of the box. So I pretty much, complained. They gave me the runaround, and then they refunded me the money. And I've never been able to use it. I gave my Pixhawk to a friend of mine who flies helicopters, and he spent almost a month trying to get the damn thing to work and couldn't get it to work. So recently, I had a little bit of extra change around and basically Amazon credits, and there was a company that was selling just the flight controller and the cabling, just some of the power switch and the speaker. It was basically a bare bones Pixhawk, and it was $60. So what I went ahead and did is I said, oh, what the hell, I tried it. And so I bought this one, and this is a Holy Bro brand, and I put it on a CD because I'm getting ready to configure it, and I do that so when I run it through the computer to do all the calibration, I can pretend like this is the drone, and I can move it left, right, up, down, upside down to do all the calibrations, where this way your GPS, your external GPS and your internal GPS are lined up together for better, more accurate adjustments. And so basically this is the new one, and I've managed to flash it and configure it 90%. So now I have a functioning Pixhawk, but I need to test it. So I'm going to make this model, the Pixhawk, use the Pixhawks and just totally go sideways and not use a DJI flight controller, and to see if I can make some use of a Pixhawk. Now, the Pixhawk, for those of you that are not familiar with it, my suggestion is look it up. This thing is, if you can get it to work, bloody awesome. Okay, this thing will tie your shoes, cook you breakfast, and tuck you in at night. Okay, and do everything else under the sun. You can add all kinds of sensors, avoidance sensors, altitude sensors, wind sensors. I mean, this thing is limitless, okay? And it comes with like a little hub where you can plug into there, and then you can add peripherals to it. So this unit is pretty much awesome if you can get it to work, okay? And I'm gonna say these are a biatch to get to work, all right? So if you want to tinker and you want to try it, it's worth it. When you get it to work properly, there's a lot of information online. There's a lot of videos on YouTube, and a lot of the guys out there, mostly in Europe, England, and so on, they're the ones who use these more than we do here. This is more of a European style thing that's really popular in Europe. Not so much here, but hopefully this will go popular soon. Even my local hobby store, which is one of the largest hobby stores in Southern California, has no clue about these things. So, but it's not their fault. So, because, you know, these things they're not really popular here. But based on my trials and errors, I've decided I'm just going to make a tinker model, and I needed a frame and all that. And so I'm going to use this as my Pixhawk. Now that I know the Pixhawk works, it does flash. The other one had some issues where it wouldn't flash, and then when it did flash, I don't know if it flashed correctly, and when you push the magic button, which is right here, the arming button, okay, Pixhawk has redundancy safety things. You have to actually push the button, hold it down, and it goes from a flashing red light to a steady red light, basically telling you that the system is armed and ready for takeoff. So it has a bunch of other features, which I'm not really going to go into at this point. If you want to know more about Pixhawks, you know where to go. So yeah, so this is going to be my next project. Now this baby wingspan from end to end is about 1 inch longer than the Parrot Ironman. Okay, and I wanted to do that. And the reason why is I kind of want to do an experiment is going with 15-inch blades. I want to go huge blades on this thing. And the idea here is to go super light and get as much flight time as possible with this. And I'm also going to go with a micro receiver on here to reduce the weight. The motors, I'm going to use motors that I currently have, which are KV900s. They're smaller. They don't have as much torque, but they're pretty decent size. They have pretty good speed on them. They're 11-volt setup, since I already have that. If worst comes to worst, I'll just get a lower size, bigger, lower, like the ones I have on my Turret. But I'll be able to go 15-inch blades easy. Yeah. So this is basically just going to be like one of those Spyder drones, you know, lean, sleek, and super lightweight. So we'll see what happens. So anyway, just wanted to share that with you guys. Hopefully this turns out. I am currently going to be printing the motor mounts in the next few days. I got done designing those, and they're going to basically be attached to the ends, and they're going to bring this thing out another 2.5 inches. So this thing is going to have a huge wingspan. So anyway, all right, guys, you take care and fly safe. Keep your heads down and watch that COVID-19, man. It's a nasty bugger.